right, over to you, Kelly. Carry on.
Good morning, ladies and gentlemen. My name is Kelly. By God's grace, I'll be taking guys on containerization, Docker and Kubernetes. So I believe, can you hear me?
Yes, we can.
Thank you for confirming that. So I believe you guys have been doing a lot for the past week, building your application, you have your artifacts, pushing to Artifactory. We are going to do the same thing in with Docker. Okay, we are going to look at the benefit of using containers to deploy your applications. Before the advent of containers, we have what they call virtualization. So this course does not covers virtualization, but you can do that on your own. Virtual machines are pretty very heavy. Like for instance, if you have a window machine and say you have like 8 gig and you want to install a virtual machine on it, it will require you to enable what we call hypervisor. And after that, it will have to take from the resources of your host. Say for instance, we have 8 gig RAM. Installing one virtual machine might take 2 gig RAM. And that being said, this will limit the number of virtual machines you can install on that host. And because it has its own operating system, the boot time is very, very long. It takes average of, like I have done that during the course of trying to learn this concept. It takes average of like 3 to 5 minutes to boot a virtual machine. So developers don't really have time. They want to do stuff in a quick fashion, deploy your application quickly. So they now began to think, how do we make it like deploy our application in a very, very fast pace? So they came up with containers. So I have a material that I'm going to use right now to demonstrate this concept to you. My way of teaching might be different from what you guys are used to. I will do the demonstration. I will explain the concept to the barest minimum that you can be able to cache it. Then after that, I will expect you to go back again to the video and watch. I believe this video will be up for like 7 days or more. Then after that, keep your hands dirty with this lab. It's pretty straightforward. Docker and Kubernetes are pretty easy, but some people would say, hey, it's the most difficult aspect of DevOps. But that is not true. It all depends on how you looked at it. So I love it. I play currently my company. I'm working with one of these leading telefirm in company here. We have over 1,500 applications. They are all sitting on containers. So it's pretty sweet. So we will see. So now let's go to our lab. Okay, before we go to our lab, let me explain the concept to you. I have this material that I'm going to use right here. At this moment, I have to let you guys know that I do not have copyright to this material. I found it on the internet, and I felt that it would be very good for me to be able to explain it. Just catch the concept. You need to have a kind of third eye to be able to catch this aspect of DevOps, containerization, and orchestration tools, we should be looking into by tomorrow, by God's grace, Kubernetes. So, any questions so far?
You haven't said anything.
No,
Okay.
not yet.
Thank you, sir. You know what? Okay. I'm glad. We'll look into introduction to Docker images. We'll be playing around with image and containers. You will be hearing more about this, especially when you are working with this concept. A lot of companies now, high-tech companies, they are on containers. Facebook, Google, Yahoo, name them. If you have an application like, how will I say, if you guys are developer application that is more than like 50, most probably they will be drifting to this concept. It's a kind of evolving trend in this DevOps space. So if you learn it now, I believe it will be pretty good for you. But not all companies are into DevOps. Not all companies, but most companies are looking, because containers is the future. So let's continue. It said these are just stories. It said intro to Docker, said the benefit over VMs. I just mentioned before. I said containers are lightweight. Containers are easy to start. You know, those are some of the benefits. We'll be looking at it where you will build in applications, packaging the kernels, dependencies, and the binaries, so that can be able to run in this environment. We'll see that. Run a little world, which is a kind of an image in our repository. So we'll create our own image. We'll see how to write a Docker file, how to create image from existing image. Then we'll create an account in Docker Hub, because Docker Hub is where we'll store our image, like you have your Artifactory. So we'll look into all that. So let's continue. Okay, I think here they use a kind of shipping transportation challenge. Okay, I'm just going to run quickly. Let's assume a lot of course are from other part of the world. I'm from Nigeria precisely. So say for instance, I want to send stuff to my people over there in Lagos. I have cars, I bought piano, I bought drums and everything. Okay, these are the items I need to ship. What I will do is I will take all these items, I will put it inside a 40-feet container. Okay. Once I put it inside the 40-feet container, I call my freight forwarder, I say, hey, I need this item in Lagos. So he will put this container on top of what? The ship. Okay. So then it will put this container on top of a ship, depending on the shipping company. It might spend like 21 days. Then it will get to Lagos. So once it gets to Lagos, it will discharge the container. I will take out my cars, my piano and everything. Then the company, the shipping company, they will take back their 40-feet containers and probably say to another part of the world, to Cameroon or to Africa or wherever. So what I'm interested in is my item. It is my cars, my goods, everything. The same thing applies to Docker and container. That is why they use containers. So we'll be looking at it where we'll be shipping our application from one environment to another. So that is how they came about this concept of container. What is container? So that is what I just explained. So I said the virtual machines, okay, said these are, I explained all this already. The same thing we have, okay, here, okay. Just put on ship. Now, coming to a real life scenario now, okay. Of course, we are aware that DevOps is a synergy between development and operation. Dave is a developer. Greg is a ops guy. Now, he's worried about what is inside the container. What do we have inside the containers? We have code that will be written. we have binaries, we have application manager, we have apps, we have data, like my car, my sheet, my bike, my everything will be inside my container. Then this guy here is worried about what is outside the containers. He's interested in the logging, the remote asset, the monitoring and everything, all stars, container and everything. Okay, now, okay, look at a case here. This developer, he wrote a code. It's a developer work in a developer laptop, but in the testing or production, it's not working. But in the developer laptop, it's working. So my code works fine in my laptop, but there is some problem with your code. Okay, this problem may arise when the dev is using upgraded version. Say for instance, he's using like Windows 7 and this guy is using Windows 10, or he's using Linux and this guy is using Windows. So there can be a kind of a disparity in terms of different version of tools which they are using. So, and this began to create a lot of challenges. And this guy was working in the dev environment. Here in the test and the production, the application wasn't working. So they now have to figure out how do we get this, solve these issues. So, but my code is working fine, but how come it is not working in production environment? Maybe the system in production, they are Linux-based machine, as I explained earlier. So these developers begin to think, how do I get this thing done? How do I solve this issue? Say code works fine, but the ops team keep on reporting error for code. I need to find a solution. Hey, he laughed. Dave, I got an idea. He said, why don't I think of this? I can use a Docker. It will package my code along with the configuration, all the tools and the framework required to run the code. In that way, it works fine in every system. That is just a summary of containers. So once I leave here, this is a kind of a use case, online shopping portal. Take for instance, let's go here. Let's see, a very good one can use like eBay. eBay is a very, all these are all containers. If you look at, if I click on fashion is sitting on a single container. If I click on beauty or this one, this is a container. So we'll look into this area later where we have microservices. We can be able to communicate. So this is where what we have here. Where we said we have account, we have catalog, we have service card, everything. So let's continue. Microservices, we'll look into that. It's the same thing. So what is Docker? Docker is to build. When you build, you have what? Then ship, run any software anywhere. It's a Docker is a tool designed to create, deploy, and run application with ease by using container. It always allows the developer to package any packaging of an application with all of its requirements, such as libraries, dependencies, and ship it as a one package. That is the summary. Kernel, binaries, configuration file, will wrap it up, they zip it up, put it in 40-feet container, you put it on top of this ship will be sailing to leave Baltimore, be going through the sea. Once it gets there, you take down your goods, then take the container back, because I'm not interested in the vessel itself. So it ensures that your application works seamlessly in any environment, be it test. That being said, it will work very well in test, in development, or in production once you package your application as a container. So once you build your image, then once you run it, it becomes a container. So we'll look into that. Who uses Docker? It tells you to focus on building things. Okay, system admin, streamline, delivery. Okay, eliminate friction in development life cycle. I'll just run through this real quick, then we'll go to our blog. This is just like, I just want you to catch the concept behind it. So, okay, now, look, grab this. We have what we call a Docker file, how we build our own image. If you build it, it becomes an image. If you ship it and run it, it becomes a container. See, you see this? This is just the concept of building it. First stage is an image, Docker image. We call it Docker image. But once you run, then it becomes a container. So the same thing I said before, like this is our Docker file. How do we have it? Docker file is used to build an image. We contain all the product code. We are going to look at the best practices of writing a Docker file. A Docker file should have a kind of minimal requirement for a Docker file to work. Minimum. We are going to look into that. It says you can run that image to create many containers as you want. So this is your Docker file. When you create that, you get an image. When you run that image, you have a container. You push it to your Docker hub where you will store them. Then from there, your container will start running your application. So let's run through this real quick. Image. Okay, we'll look into this one, how to write a Docker file, all this stuff. We'll see them during our demo. Building Docker file, then storing it in our Docker hub. So we see all this one. Images, we run it, becomes a container. Yeah, we are going to look at custom image, which is very popular for tests. It's called Hello World. In fact, you have to see that now. So we'll be playing around with repository where we store our containers. We'll be playing around with tagging, how to tag your container. As a DevOps engineer, minimum, you should know how to tag your container. We'll be looking at Docker, the image ID. We'll be looking at the created. We'll be seeing all that and the sizes. These components are very, very important for us as a DevOps engineer. So we'll also be looking at container ID, image, command, create, status, port. How do you expose your container? This Docker will also be looking at Docker commands. Okay, how to search for images, hello world from repository, how to put your images. All this we'll see during our demo. So search hello world. Okay, so I think these are the same thing. Okay, okay, as I've explained before, like in the case of containers don't use their own operating system. They don't have it. They use the host operating system. We're going to see during our lab. Okay, say for instance, you are hired as a DevOps engineer. Say we are using container. They might give you a Windows laptop, or they might give you a Linux Mac. So whatever type of laptop given to you, we have a Docker version for that. What you need to do is just go into internet, go to Docker. This is the official website. You have different product. You have, let's see, yeah, I think you have different, yeah. Okay, hold on. I think Docker for Windows. Just say Docker for Windows or Docker for Mac. See this out. You can go here and install Docker for Windows. Then if it is Mac, the same thing applies. So but in our case, we'll be using Ubuntu, where we'll have our own Docker demo sitting. Okay. Okay, another thing, we'll be looking at this command is very, very relevant to us. We'll be looking at interactive, then connected to terminal detached mode. This is how we run our Docker. We run Docker run interactive, meaning come out of the shell, If we are going to run in interactive mode, meaning we want to go into the shell of the container, we will see all this, don't worry. During our labs, we keep this. In 5 minutes, we'll be keeping our hands dirty. Okay, binaries, you see, virtual machine, they have their own operating system, but in case of container, they don't have it. I think that is all now. So let's go to our lab. If there's any question, you have to ask now. Otherwise, we want to keep our hands dirty right here with lab 21. This is the information I have.
Can
now.
we access this material? Hello, my brother. Good morning.
Good morning, sir.
Yeah, please. How can we get this very material you have explained to us?
During the time I was trying to learn this concept, okay, it was a material. This was one of the company that I used. So I have a kind of lifetime access to it. If you looked at it, I think I signed it here. You see, I have a lot of information here. See, did you see Kelly here?
Yeah.
I've been trying to download it. I will try to download it and share with you. It's supposed to be for my private information, but I will see if I can be able to download it and share with you guys.
That would be awesome.
All right. Thank you very much. Okay. Yeah. I will do that. Just remind me.
All right.
Yeah. Any other question? Okay. Let's everything that I've explained. Okay.
Sir,
yeah, go ahead.
please, I want to know the difference between deploying to container, Tomcat, and deploying to Docker.
We are going to do that.
Okay.
We will do that. You know, every web server, you know, we have different kind of web server. We have Tomcat is there. We have Apache. I believe you guys are familiar with Tomcat already.
Yeah.
Then we have AGNS is there. We have JBoss is there. There are a lot of them. They are all application web servers. Okay, but we are going in the case of our lab, we are going to use AGNS.
Okay.
But they work in the same way. It doesn't matter. But we are going to see that how we deploy application on that. We'll wrap it up already. So now let's go through this one real quick. The same thing I've explained. Take our time to read all these stories. I have explained everything here. Now, see, by God's grace, where I currently work, my boss called me and said, hey, just conduct we need some DevOps engineers. We conduct, and they gave me the responsibility of hiring them. Just imagine that. And I've been dealing a lot of with our people. So yesterday he told me, hey, Kelly too has just been hired. So I'm glad, you know, bad guys and everything. So, but I will tell you my questions that I'll be asking them. You can be able to grab it. Like, for instance, I ask you, can you explain virtualizations to me? Okay. If you just give me something, then containerization as well. Just lead you. I just want to hear the keywords. Once you tell me, so I'm just okay, fine. Go to the next question. There we go. So please take our time. It's not difficult at all. You just go. It's virtual machines. How you use a virtual machine. But in our case, it's a containerization. It's a type of virtual machine. We bring virtualization to the operating system. Okay. To the hardware. Okay. So now the reason why to use container have no guest operating system. It doesn't use the guest operating system. Okay. It doesn't have its own. Okay. Then it uses the host operating system. Because of that, it's a lightweight. It's very light. We'll see that. You just start your application. You can stop it. You can start easily. You see your application running. So the same thing I've explained here. You see, container is here. This is your host. My host can be your Windows machine, can be your Linux. But you see the binaries, they are now sitting on the host operating system. The same I've explained here. We have our Docker file, which we are going to see how to write it. Then once you build this file, it becomes an image. Once you run this image, it becomes a container. See, what is a Docker file? It's a test document which contains all commands that a user can call on the command line to assemble an image. We are going to see that. If I use your Docker file to create your image, that's it. Where's the Docker file? You use Docker file to create image. There's nothing more than that. You can add any other English as you want. Then we have, Docker image already. Once we run that, then once we run an image, it becomes a container. Then we'll go to Docker Compose, where we talk about microservices, how containers communicate. Because I don't know, the container is so unique. Okay, containers have their own virtual IPs. We are going to see that they don't use their, because they communicate among themselves. So because,
and that's an example that you used the microservices for the eBay example.
Yeah, correct. Absolutely correct. Yes, absolutely correct. Because they come, see for whatever reason, say, okay, let me go back to that image again, eBay again, because they have their virtual IPs. If, let's assume, this container, sometimes you go to some website, you click on something, it shows you error, like this fashion. Maybe this container, for some reasons, it has problem, it's dead, it's not responsive. It does not bring down this website down entirely. Instead, when traffic comes in here, instead of routing to this fashion, it goes to the other one. But in the case of monolithic application, it doesn't work like that. If you have problem, okay, monolithic application. See, we have them here. Application. Okay, you just say monolithic and microservices. See, in the case of read this up, it's very interesting for you to grab the concept. Just go on the internet. I wanted to show. Okay, see, okay, now this is a monolithic application, guys. This is why it's very risky for company to run a monolithic. You have a web server. Don't forget, like if you have like a website like this, like okay, Vanguard is some microservices. Let's say for instance, this company is running on this is a website which people are seeing all over the world. Don't forget, this is the way we have that web server. Sometimes you want to download you have a database. Maybe you want to click on a place and say, if you want to shop, you click on database where you input your user's ID and your password. That is behind. You don't see that very well, but this is what people see. This is just the front, the web's front. Now, this is what we have here. Now from the back end, which is the database, you have the database, you have, for instance, you want to download data sheet from the site. If for whatever reason there is a breakage between the front end and the back end, you always hear front end. Okay, front end is what people see, back end people don't see behind the scene. If you break and you are running on a monolithic structure, your site is going to be down completely. No doubt about that, because there's breakage in communication already. But in the case of a microservices, if for whatever reason this application is down, this container is dead, it can happen. Of course, it can happen. Then once traffic is coming, instead of routing to this container, it divides and come directly here, go there. Then it keeps until, for whatever reason, maybe Docker daemon is sending a kind of API, say, hey, my friend, you are sleeping, what is happening? You are not responsive, what is going on? Maybe then the Kubernetes have to spin up, we keep sending a kind of API to see a kind of responsive request to see why this container is dead. So if you try couple of times, if it doesn't wake up, it can spin up another one. We'll look into all that tomorrow. So that will now make sure that your site continue to run, irrespective of what happened to one pod or one container. But in the case of monolithic structure, that will not happen. Your site will be down. This is the reason why people companies are especially moving into one of the reasons, not the major, one of the reasons. And if you also have another reason is if you are running an application that scales rapidly. Take for instance, they do Black Friday. I think sometimes they shop where Americans, they keep their dollar and want to shop all the goods for the year. If you don't have a kind of microservices application where people want to be hitting your site, I don't know, thousands of people simultaneously, so that this application should be able to, the Kubernetes will keep spinning up the containers and people respond, your site will be down. And if for whatever reason, Amazon, where people shop, is down for 5 minutes, believe me, they are going to lose. You know what they will be losing? They will be losing a lot of money within 5 minutes. Just say this one. People are hitting it. Yeah. And companies don't want to lose money. They don't want. So this is why they are really going to, like, all these are all into containers now. Everything right here. Google, Facebook, name them. So thank you very much. If there's any other question, just bring them now. We want to keep our hands dirty, meaning we are going into the lab. Go ahead, sir. Go ahead, sir. I'm right here.
When you say use the host, not the guest. It's
Sorry?
like when you say that use the host,
Oh, correct.
not the
You
guest.
are talking about Docker demo, right?
Yes.
Yes, go ahead. Yes.
So what you mean is like, if I log in maybe from like the way I'm logging into this Zoom, right?
Right.
So that means Zoom is using my host laptop, which is my laptop to log in, right?
Right.
Okay.
Yeah, correct. So we are going to see that now straight away. Okay. Now I want to spin up this lab. Try to use Ubuntu 20. Okay, 18, and because of I think security and dependency issue, 16 and 18 may not work. I just tried that yesterday. So try to use 20. I'm going to spin up Ubuntu 20. Yeah, just go here, just pick it up. It's lightweight, can take 2 T2 micro, go then I will choose one of my security group, but this I'm going to edit later to show you how it works. So as I said earlier, it can be your Mac, it can be, but now for the case of this lab, I'm installing Docker demo on Ubuntu, which is going to be my host right away. So I think I have mobile S10 here. Okay, got mobile. So start my mobile S10. Delete that. Let me refresh to bring this one up. This security group, let me edit it so that edit it. We'll come back to work on all this later. This one, okay, 8080, port 22. So now, okay. So first thing I will take, I know you guys are familiar with this very one already. Okay. Let me initialize. Take my public IP. I want to connect to this machine. User is Ubuntu. Take your private key, which you already downloaded. I think my private key should be somewhere here. See, I'm able to access this machine also. The first thing I always like doing, if you looked at it, you have Ubuntu here, but in most things I like doing, I always like to go to the root, sudo -u. I'm already in root. You clear your terminal. Let's see if you have a Docker already in this host. This my host right now is here, is this Ubuntu, as I said. So I want to put a Docker demo where we make a kind of API calls to where we'll be creating image and all those kind of stuff. So what you do is, how do you check? Is Docker version to see? Did you see that? It's not on this machine. So if I also do, best way I also want to check if Docker is running, in most cases, I do Docker images. It's not there. So what we do, we are going to install Docker on this machine right now. So you go to your lab. First thing, you update the machine. Just a normal sudo apt. As for why. No reason why I put why, so that's the prompt for yes. Then the next is sudo apt install Docker. This command is going to install Docker. Okay. They're asking for why. Continue. It's installing Docker now. Guys, you guys listen attentively. I'm going to be shipping some information that are not probably part of this blog, but it's might be very useful to you. Then you start it. You have to start Docker. Then you check. You have to enable it. After you start, you enable it. Let my terminal. Then I check if Docker is already there with this command, Docker version. This is said version is 20.10.7. I think these guys are pretty fast. It's keep increasing every day. So that's proof that we have Docker already. If I do Docker images, awesome. I see my repository, I see tag, I see image, I see create, I see size. You see what I explained earlier. These stuff are all very, very important. We'll be looking at them, how to use them. Now, I want to run a command, sudo docker run hello world. Now, one of the questions I'll be asking some of these guys is, what is the difference between Docker run and Docker start? Expo, I'm giving you guys Expo now. Can never tell, maybe you might be the next person that they are going to contact. So now look at it. Docker run is going to take the image and put it into what? A run state. But when you say Docker start command will start an image that is already in a stop state. We are going to see that. So where is it going to get this image from? We'll see. Let me run this command. Just watch out and see. If you looked at it here, it said unable to find this image latest locally. Locally means this Docker demo made an API call to my local. My local here now, which is my host, is my Ubuntu machine. He checked inside, he checked everything, he couldn't find it. So what he did was that he now went to the repository internet and pulled it from the internet. Let me show you where he went to, guys. He went here, Docker Hub. Let me sign in. So it's pretty easy to sign. This is where we'll be storing our Docker containers. If you have not signed this, it's free. What you do, just sign up, click on sign up, choose a name, Docker, and then ID, then create an email, create a password, then sign up. I already signed up, so you can do that. Pretty easy. So I'm going to sign in now. This is my user ID, this is my password. Now, this is the Docker Hub. Docker Hub is like your Artifactory. If you look at it, you guys have been building, and it's just the same thing as your Artifactory. Let's see where he got this hello world from. See, hello world, this is where he put this. It's an official image. It was just updated 43 minutes ago. You see, it has been put over 1 billion plus time, because in fact, if you are learning containerization, it's one of these custom image where people play around with. So if I do Docker images, did you see that? Hello world repository. The tag is the latest. This is the image ID. It was created 6 months ago. The size is 13.3 KB. We are going to let's look at the Docker file they use in creating this hello world. See, let's see. Okay, this is the Docker file from. We are going to see our own Docker file, don't worry. Copy. We are going to see these are some of the best practices of, I told you, a minimal requirement for you to write a Docker file. These are some of them. Now, let's come to a real life scenario. Maybe you are working in any company. The best practices of writing a Docker file is you use a form and you must use your base image. We call it base image. Your base image is going to transport, is going to serve as your ship, like what I explained to you initially, that it will just ship your application through this environment, but we are not interested in that. We are only interested in our application. Okay. So I try to come. So we'll be writing our own. Let's continue. Now, this is what we have here. Now we want to create our own Docker image right now. So I'm going to delete this one. Docker ROMI F. This is the command to delete. I'm going to see. I already deleted. As a DevOps engineer, guys, I will advise us. You should be very comfortable with minimum of 10 to 15 Docker commands. Let me put 15 best Docker command. Let me see commands. We'll be playing around with some of them. Let me see if this gives us a, okay, awesome. I'm going to share this link with you guys. We are going to see Docker pull, Docker run, Docker PS. Sorry, guys. Okay, let me pause this. Oh, make it too much noise. We are going to see Docker exit, how to stop, Docker kill, Docker commit, Docker login, Docker push, Docker image, ROM, remove. This one will remove image. This one will, no, ROM will remove container. ROMI will remove image, Docker build. Let me share this one with you guys.
Yeah, I was gonna ask you with that. Okay,
yeah, you're welcome. Let me put it in chat, Zoom chat here, this link. Please, guys, save it and play around with it after this lab. Okay. You see, they also explain it here. Just follow through. Once you are at least comfortable with 10, you are good. 10 or 15, or stretch it further, take it, no kill, every commit. We are going to do all this logging, we'll do them, but let me keep it right for you there. So let's continue, guys. Now we want to create our own custom image. If you looked at it, I already deleted this Docker. If I do Docker images again, you see there's nothing will be in my system. The reason why we do clear we do clear images in real life scenarios, that because if it doesn't clear them with time, these sizes begin to increase. This can slow down the speed of your machine. Okay, say you guys are deploying containers. The best way to do is that once you build this container, you push it to what? To your repository. Your repository can be on AWS has one, then Docker Hub is, of course, that is popular. Then you can have Azure has their own repository. Google Cloud has their own repository. It doesn't really matter. But repository. What it does is you just store the container here. Okay. So now we are going to make a directory called images. Of course, you guys are familiar with mkdir. So once you do ls there, you see your images. You go into images. So we clear it. Now we are going to what? Create our own custom image. I'm going to use VI, then use a Docker file. See, I will just do this VI Docker file. See. Some people will tell you Docker will start with capital D, some will say small d, but in most documentation I do see capital D, so I'm familiar using capital D, Docker file. I just enter, press I. I have a Docker file that is already written here. See, in a real life scenario, in most cases, you might not be writing this Docker file. I'm going to explain this to you. The developers might be the people writing it in most companies which are involved. But managing these containers, creating it, pushing it to a repository, you say, hey, Dave, we want to deploy version 346, something like this. Your duty is to go into your repo, take that containers and deploy into your target environment. That will be your responsibility. Some Docker file can be very, very lengthy. I don't know what they wrote there. But as a DevOps engineer, there are some basic things you need to look out for, which is minimal requirement of having a Docker file. If you look at this, let me go to the official document to see. Let's go to Google, best practices of writing a Docker file. I also add this question in most interviews I have conducted for some of our folks. Best practices of writing a Docker file. What do Docker files should contain? First and foremost, it starts from. From is our base image. Our base image in this case is the one that is going to transport our application to different environments. It's a must. If you open the Docker file, didn't see from, how is it going to work? It will not. So that base image can be Ubuntu, it can be an Alpine, it can be, name it, MySQL, PHP, as the case may be. Then you have a copy command. Copy is going to add your files, which they have been created right now. We're going to see that. Then a copy into the current working directory of this container. Then we have run. It's a run command. Run command, you are telling a Docker command, I want you to run this application. The CMD, I think there is another one we call expose. It's very important. Expose is going to expose your application to outside. As I said, containers, they communicate, they have their own virtual IPs, which they communicate. For you to expose them to outside world, you need to have a kind of expose command. So that is very relevant for us. I think it's right here. Okay, I have it in our blog. See, here, I said from is the image that has to be downloaded, which will serve as our transporter now. Maintainer is the owner. You might not see maintainer in all the Docker files because if it is official. So, but sometimes it's the owner who wrote it. Then run, it specifies the command to be executed. Then we have the expose and entry point, which specify the port which this container should be exposed. Normally, it's a kind of cluster. For it to communicate with the outside, well, you need to give it a what? an expose command. Let's go back to our Docker file. Here I have Ubuntu maintainer. Let me put my name as maintainer. This can put my name here. Can change it. Kelly gmail.com. Now I say run. See, look at the instruction I'm giving. I say this container, please update it. And another thing, I say install an AGNS. Okay, AGNS is a web server. I say install it in this container. Then this entry point is, I said, as given an entry point where this container should run in a 4 background. It will run in a what? A 4 background. Then I said what? Expose this application on port 80. What that means is that if there's any traffic coming externally from outside the container, is on coming through port A0, please allow it in. Give it, I want it in. This is the purpose of expose. I've asked this couple of times. You use your expose command to expose the application externally. That's it. It doesn't. So guys, I'm doing. So you save it. Now, if you do ls, you see my Docker file is already ready. Now I want to create my own image. So look at the, look at the command to create your image. See, Docker build -t tag, the name I'm going to call this container, this application. You in real life scenario, yeah.
What does the -t stand for?
Tagging, tag, the name, yeah, tag. Say for instance, I want to do dev champion app. I can change it. App space though. See, in real life scenario, this to differentiate your application. You don't just put any name. Your manager is going, in fact, the developers will tell you the name of the application, maybe one thing. But just know that iPhone is the name we want to call it. But in this our case, I just call it app. See something here. Don't forget, once you write the name, always leave a space and put dot. If you don't put that space and dot and run this command, it's not going to work. The reason is the Docker daemon sitting on here. He tried to make that API to get the Docker file, but the guy was confused. He was like, I couldn't find the Docker file for me to create an image for you. So what do? You go back again, you put space, you put dot. This does means telling the Docker daemon, hey, use this Docker file that is currently in this working directory. Press enter. Look at the magic that the guy is doing. Look at, he's pulling the dependencies. It's the kernels, the binaries, is writing it up. You see the everything for, it's wrapping it up from internet. That is where it's downloading all the stuff. Now it's creating everything. I'm going to see also.
I have a question, another question, please.
Go ahead.
So about the period, what if you have another file in that directory aside from Docker file? Will it specifically go and pick the Docker file?
We will get there. We will get there, sir. We are going to do that. That is what we call Dockerizing an application. In fact, in real life scenario, that is how it works. We are going to do that one in the next slide. Don't worry. Okay. So now, if you let's go through this log and see what this guy did. See, if you look at it, first and foremost, you see step 1 of 1. He picks from my image, he puts it down. Step 2, maintainer Kelly is there. 3 is running the update, everything. Then downloading all the packages, binaries, and everything. Let's see step 6, 5 or 6. 5 or 6, the entry point is running on foreground. Then he exposed it. If you look, it says successfully built. And the way this Docker images does, it always gives you a kind of random numbers, like a kind of string, you know. So let me do, so once you do that, you see, you now do what? Docker images. Just type Docker, I can type that, but let's go through the lab. Guys, did you see what happened here? Let's look at this closely. Did you see Ubuntu? That was my base image. This is my base image. If you look at Champion app, which I tagged the application, is the latest. He gave it a kind of image ID. It was, if you look at the time, it was created just 1 minute ago. If you look at the size, now is what he created. This is 162 MB. The reason is it has already packaged Canes banner, they wrapped it up. So what I'm interested in this case is this my app. This Ubuntu can go. This only serve as my vessel that transported my 40-feet container to Lagos. I can discard it, but I'm interested in what? In this my Docker, in this my app. So we haven't got the maybe it's if you do Docker image, you have it. Now, I want to run this application. I want to see it. How do you run it? Okay, this is how we run. I already created what? An image, but I need to run it. Once I run it, it becomes what? A container. Okay, so maybe I think, okay, we'll do that one, how to tag and push to in our next lab. So this is how you do Docker run. As don't forget, I say IT is interactive if you want to go into the shell. But when I use iPhone ITD detach, okay. Now this is what I'm going to do here. I'm going to do this one. Copy this command. I'm going to put it here. Excuse me. So then the what? The image ID. So I said use image ID. Where do I get the image ID? I got the image ID after I run the images. I just put it here. Did you see that? You just, okay. Now, what you do, how do I see this my application to see if it's running? I go, okay. I go straight, copy the IP address. Do Docker PS iPhone A. So see, now another thing, this is how you see if your containers, if you want to find out if your container is running or not, is once you do this command. Some will say do Docker PS. Docker PS is going to name the container that is in a stop state. But for me, I like going with iPhone A. iPhone A is going to list both the one in a stop state and the one in the running state. If you see exited, know that your containers is in a stop state. But if you see up, okay, you see it has been running for over like 3 seconds. 33 seconds. If I do that command again up, you see the time is going to change about 1 minute. So you can always go into you can run your command. You can see some containers have been running for like over 700 days. It has not stopped. In real life scenario, you see 300 days, 65 days, as the case may be. This is how you see that. So if you look at it now, originally it's on pause 0, but right now it's saying that any application coming in, because I was the one that determined that, but if you are working this port, you don't just put a random port. Your manager is going to tell you. They can tell you, oh, this application want to expose it on port 777, 888, 99, as the case may be. But here I said I want it to communicate on port A0. A080. So what we'll do is that we go here. I put it on A085, right? Is that what we have there? If you look at this stuff like this, it's just rolling. This is like a kind of security that is going to time out. So what do? We go to our security group. Then we are going to expose that. I'm going to say custom port A0. 85 from anywhere, then save it. So did you see that, guys? This is my web server, AGNS. Now let me demonstrate. Let me see. Okay, 3 minutes ago. Let's do Docker stop. I'm going to stop this container now. Then let's go back again to go and check. Guys, it's timing out. You will see. I want to start this container again to tell you why containers are pretty light. You can't do this in virtual machine. Start again. Did you see? Just a fraction of seconds is up again and running. But virtual machines are very heavy. It takes minimum. It will boot. So with this very concept, developers were pretty very happy because the speed is lightweight. So now let's see. I'm going to do Docker network ls. Okay. Now we are going to see. Normally, as I said, the way containers are being designed, it communicates as a bridge network. You see, a bridge. This is how, like a ring. So by default, it's always on bridge network. This is how it is. But if for it to be able to communicate with outside world, now don't forget this is sitting here. It has to be on host network. So let's see why containers communicate among themselves again. I want to see Docker inspect. I want to inspect this container. Let me see the IP that is using. Okay, see, look at this method. It see all the information about the containers. It will give you so many things here. Is it in the running state? True, it's running. Status is running. It gave you a string. Then let me see. By default, it's on bridge. It should be somewhere. It should be somewhere. Let me see. Yeah, network mode by default. Okay. Image. Now let me see the IP address that this container is using. Hold on. This is how we inspect containers.
I have a funny question.
It's not funny. There's no funny question. Go ahead.
So question, is there a way on this instance, like you can do control find to find certain things. Is there a way to put a certain command where you're not like flipping up and down to find, like example bridge, even though we have bridge right there, is there a way we can find it?
I'm not too sure. I'm not too sure about that. Command F. Normally, if you are using like, I think I use Command F, but I've not really tried that. Yeah, but I already find that. Just try to check Google to get details. Yeah, you see, I told you by default is what bridge, because normally it's been created like once you create your container default. One time it's on bridge. Now let's look at the IP address I was looking at. If you look at this 127.17.0.1, let's see the IP address of our host. Let's look at the private IP, if it's the same thing. Hold on, I want to double check, but see, did you see 172.31.16.206? But here we have the IP address as what? 172.17.02. So every container you create, it has it. I don't know how they did it. It's, to me, it's still like I begin to think. So if I say, for instance, I have like 3 containers here sitting on my host, and they will use this, they will create a kind of virtual, this information is not in the blog I'm giving you now. They will create this virtual network and they will use this IP to communicate among themselves. That is why we have it as a cluster. That is how it's communicated. If you see, it has its own gateway. It created its own separate gateway. Everything. It has its own MAC address. See, that is how we. Any question, guys? So let's continue with our. Go ahead, sir.
So for those virtual network that was created, what are the functions of those virtual?
But just like I said, if you know, I did the Docker, sorry, let me Docker network ls. Ls means list. It's a daemon that creates this. You see, it has its own. It comes by default on bridge, but there are some scenarios which might be very rare that you want to create your kind of network. You can use to create that, but I haven't really seen that in real life scenario, but you can see people does that as well. Maybe you don't want to use a default, which is bridge or host. You want to give it your own network, so you can be able to create that. But that one, I don't think is practical, you know, in terms of real working this. But what you need to have in the back of your mind, because like some people used to, how do containers communicate? Just tell them that container communicate with the help of a virtual network, because they have their own. If you see that, I showed you the IP address now, which this container has. It's different from the host IP address. If I have 5 containers here in this host, believe me, if you go and inspect each of those containers, is going to be different IP address. So okay, it's the daemon that is responsible in creating that. You are not the one. This is what they kind of make a kind of API calls.
Okay. So the other time when you showed us the architecture of those containers from the back end with those diagrams.
Correct.
So does that mean, and they have a lot of traffic, like different connections.
Correct.
Does that mean like those IP represent those?
Correct. Absolutely.
Connection. Should in case one get blocked, then it goes to another route.
Exactly. That's it. Those are the IP that they'll be using communicating among themselves. Exactly. Correct. Okay. All right. Let's continue, guys. Docker images. I'm going to clear everything here. Now, let's see. Now, this is the rule. PS. For you to delete a container image, you must first delete a container. Let's demonstrate that very well here. It's not in the lab. Let me delete an image. It's going to tell me, oh, it's not possible. I'll do Docker.
You will put it in the lab, brother.
That is why I said play with 10. I just gave you 10, 15. It's there. It's something that I want you to catch on your own. Okay. Now, this is the thing. ROM. You will know ROM is to delete a container. ROMI is to delete image. I will use I. I'm going to say iPhone F. I want to delete this image. This image here is image. Look at it. I'll take the image ID. Let's see. Did you see what he said? He made, and the Docker daemon made an API to delete. He said, response from the daemon. He said, conflict, unable to delete this, cannot be false. Image is being used by a running container. It's a normal rule. You have to delete the container before you delete image. Okay, now let me delete ROM iPhone F. See, container, ROMI. ROMI is for container. I want to delete the container now. Where's my container? I'm going to take the container ID. You can delete multiple containers. Okay, so just put a space. I think I have another container. I can put this one here now. If you have them, enter. Both of them already deleted. Let's go back to see if our site is still there. Our site will no longer be deleted because I already deleted that one. It's gone. Now let's delete the image now. You see? Did you see? The image is gone. If you do Docker images now, Okay, now there is a command that you can use to clear. Maybe you have been building. I remember the first time I started working on containers, my manager said, okay, the images they've created like past 2 3 years, they tell you, okay, put them down and retag them. They created a new repo. Your duty is just to put them down, retag them and push it to a new repo. So over time, your local, it will be building up. Okay, so you need to clear them so that it will not slow down the speed of your machine. So you do Docker. I think there's a command called Docker system pro -A. Now it's telling you, warning, are you sure you want to continue? This will remove all sub containers, network, and everything big as it's going to put where. This is that it said total space reclaim 72 points. So now there is not. If I do Docker images, we don't have it. If I do Docker PS-A, nothing right now. Come again. Someone was asking a question.
I have a question.
Go ahead, sir.
So when you prune, does it delete all the containers?
Yes,
all you remove them and put them in like this bin
a cache.
Like when you need it or something happen in the future, you have to like you can easily go there, like you recycle bin. Let me just put it that way.
Is that what?
Like what I'm asking is like when you prune it, does it delete it completely?
It can remove it completely. It removes it completely. Yes, you don't get it anymore. So that is why it gives you that warning. You say it's going to remove even both the cache and everything. It's going to remove it completely. So that is why once you build, push it directly to your repo so that you can have access to it later on. Okay. So I'm going to remove that directory which I created so that we can go to the next lab. Any other question, guys? So now our machine is clean.
I have a question.
Go ahead, sir. Go ahead.
So as soon as you've done that, is there a way for you to recover that file in case like anybody needs it or no?
Which file?
The one that you in the Docker image that you just deleted from the...
It's in the blog. I just removed that Linux, right? I think that would be outside the scope of this job. You have to go into Linux to see how to recover those images. But in most cases, I think you can recover that.
Let me add something. Let me add something to what you said. Now, the whole point of clearing your system is so that you have a clean slate.
This one.
Okay. That's the whole point of Docker Hub, so that you store your images there. If your images are in Docker Hub, you have a copy. So wipe it you have on your server, you have Docker Hub to rely on if you want to recover anything.
Does that answer your question, sir?
Yes, sir. Yes, sir.
Thank you so much. So someone asked a question before to copy. Now, we used to use this terminology in this so Dockerize an application. You can Dockerize any application, be it Golang, be it Python, be it Java, be it C++, I don't know. Any application, because the developer they write it. What you have to do, you just put your application in a container and run it. That's it. You should be able to run in this different environment. In this lab, I'm going to demonstrate. I don't have a development skill, unfortunately. Sorry about that. I'm going to do like HTML. It's a simple HTML. I want to put it on a AGNS web server. I want to see it. I can take this IP, I give it to someone in Singapore, he puts it on the computer, he will be able to see my application live and direct. So this is the purpose of this lab, HTML. Maybe in your real life scenario can be Python, Java, name it. So first and foremost, I'm going to create this file. Okay. I just write, this is simple dot index HTML, press enter, press I. Then I have a small text here, which is HTML, sorry. Just paste it here. Of course, as I said earlier, the developers, they will be the one to write all this. And they will just, let me edit this one, let's to see. Let me do it a little. Add something to this stuff. Okay. This one again. I wanted to edit. Okay. Hold on. It's a bigger. Hold on. My machine acting up. This is why I don't like using the C2 micro fitting. It's free, but sometimes the speed is not there. Okay. Let me see. Nice working. Is the speed around? Sorry, guys. Okay. I just wanted to demonstrate so that you can see how I want to write something. Say we are champion and we are leading. Okay, this is my application in HTML. Okay, I save it. It's ready. Now, what will be the next stage? The next stage is for me to create a Docker file. So it's like I should Dockerize this application. Go back to the blog. I said what? Create a Docker file. Then see Docker file. I'm going to enter, press I mode. Then I will come back and copy this information here. And, let's see what is inside. I said from what am I using as my base? A GNS. Go on internet and take the latest. Now look at the command. Copy index.html into this location. See, every web server has their own location. Prince, can you remind me Tomcat? It has its own.
Tomcat is in slash web apps.
Web apps, correct.
Web apps folder.
Yes, web apps folder. Yeah, you're right. So, but AGNS is in this location. So, irrespective, just go and get the location where you have to copy it to. Then I said expose this application on port 80. See, just a simple Docker file. Okay, as I said, some can be very lengthy, some can be very short. So, but what you have to do, they just give you a Docker file, go and look at the base image, look at the expose copy code. I think those are some of the things you might be interested about, not the other stuff that they have there. Now I want to Dockerize my application. Pretty easy. Go back. This is what we have here. Now we are going to use this command which we executed earlier. Now web app, you call it any name, don't forget. Let's call this one DevOps app. Okay. Your developer will tell you, or your director or boss will tell you. Again, don't forget the space. If I don't put space, it's going to be error. Put a space. Put a space and put dot. So in that way, the Docker daemon sitting here will understand that use my file in this current working directory. Okay, I think you understand that line of pwd. Yeah, /home or whatever. So I just go space and look at it. Did you see? Now it's pulling, it's building my application, it's wrapping up in a container. Did you see that? It said it copied it, step 3 of 3, copied it into this AGNS, and it is exposing this application on port 80, successfully built. Let's go to the lab and see what he's saying. We say when you do Docker images, it's going to list. Sorry, this lab, we have so many images that we have. That was why it was so lengthy. So if you put Docker images, you are going to see. Did you see? AGNS, which was my base, is there. It was updated, created 8 days ago. Now, this is what I'm interested in. The was latest. It was just created 19 seconds ago. The reason why the size is the same is that it's not a big application. Remember, I just wrote, I want to be a DevOps engineer. This is why this check, but in real case, it will definitely change the size. So I'll be interested in this DevOps and forget it by engineer. NGNS has done the job just to transport it as a base and be able to carry it for different locations. So that is what we have. Then the next thing is for me to run this image which we are created to become a container for me to see the application live. We're going to use this, let's run the image. We are going to use this command. See, port. For peace, I'm porting this container to listing on port 8080. I can change it here. Sorry. Let me put 9,000. You see. 9,000. As I said, you don't just go there and say, hey, 333. Oh, no, you don't do that. They will tell you, say, this is the port. So you have to follow that instruction. So I'm using 9,000 here. Take image ID. Where's my image ID? Now I want to run it now because it's an image right now. I want to run it to become a container. I will come here and take the image ID. Just press enter, IT, detach, come out of the shell. We'll also use IT later. Did you see that? Then if you do, okay, I wanted to do that, but let's go back to the lab. Do Docker -ips to see, check if this image is running. Just do this one, fs to see the image is running. Did you see that? Image is what I said, the status is up. Once you see up, you know your image. Once you see exit, you know your image is in about stop state. Now, this image is running on.
I thought once we see up, was it exit or stop or something like
that? Exited means the container is in a stop state. Yeah, correct. Okay. Once you see up, know that your container is running. You can equally do that on your local. Once you just run this command, you don't need to go to website, your web to go and check it. You realize they may not even have access to the web. So you can do that, just put this command. You just see, once you see this up here, no, it's already running. In fact, this is how we just check it out. Once we deploy into your target environment, you just do this activity and see your Docker, your container image, the name is there, it's running, then you good. Okay? So now, but now let's check it out. We want to see that application that we just Dockerized. So what we'll do is we'll go to our, take the IP address, what we did earlier. We are going to take our IP address. We'll put it on 9,000. This looks like a security issue. So it's the same thing we did earlier. We'll go to open that port so that I should be able to send traffic to the container. So I'm going to edit it now. I can use the same one I've used before. Let me use this already, or I can add another one, 9,000.
In real life, if you know all the ports you're supposed to work with, you can just create this and save all the
Correct.
time.
Absolutely. That is how it is. Absolutely. The port will already be created. The cloud architect, they already opened it directly. So your own is just to maintain that port directly, which already be created. That is how it is. You're right. Yeah. 9,000, I just save it here. You don't need to come here. You may not even have access to your AWS. So, did you see my guy? Did you see, this is awesome. Did you see my HTML application that we just Dockerized? We are champions and we are leading. If I take this IP and give someone in Africa and I put it in his browser, he's going to see this application running live and direct. This is how you Dockerize application. You might find yourself in a different environment which they use different application. In most cases, interviewer will just ask you, have you written a Docker file? You say yes. What are in Docker file? we have the base image. Say, tell them a Docker file contains a base image. It has the expose command. It has a run command where you run your application where it tells the Docker. That's it. Don't all those other stuff, because can be, especially if you are your potential company might developing a Golang application. Golang application goes with a lot of dependencies. You will see, you open your Docker file, you see up to like 100 lines. I don't know what they write there. But what I just go in there is just to look for 5 basic things. From what image are we using? What is the port that we're exposing them for? And maybe check the CMD. Every other thing they put down, copy environment, copy this. I might not be interested in that. So this is how we Dockerize our application. Any question? We are going. We are. Then, yeah. There's no question. We have already looked at one way of creating a Docker image from scratch using a Docker file. We want to look at another way of creating a Docker image. We'll create a Docker image from existing image, but this way is not too common. I haven't really used it, but it's better for you to know it. So we have existing image, you just create an image from it, okay? So this is what this lab 23 and I think is lab 23 and lab 24. I will use lab 24 to explain it better. So that will be the same thing, just commit. Yeah.
Are you creating from an existing image or an existing container?
Existing image. Don't forget, container is in the one that is in the running state.
Okay,
image is in stop state, so it's already there. I want to create my image, then I can be able to run it. Yeah, so it's a 2 ways, but as I said, it's not just, I haven't seen it in practical terms, but it's good you know that. Yes, someone was asking another question.
Yeah, just not a question, but I just want to have like a more clear understanding, of what we're doing. Because like the result we get here is the same thing like we actually have gotten using Tomcat in our previous labs, but here we are using the images, a container.
Yes.
So what are the like main significant differences and the more benefit of it? I understand about the architecture which you explained earlier,
okay.
but I just
the benefit is this: if you work in a company that's that have their application that scales rapidly. Say for instance, I told you currently I have 1,500 applications that I'm dealing with. Okay, these applications want to be able to communicate among themselves. You cannot, the best way for you to do that is through microservices, a container which will create a kind of virtual network where they can be able to communicate among themselves. And if you work in a company that scales rapidly, the best way for you to go is going on container. As I said earlier, containerization is a kind of concept that is really evolving. Not all companies are into it, okay, as I said, but it's the future. But most companies are moving into that. They will, sometimes you take an interview, they will tell you, okay, we don't use containers now, but we are looking into that in future. If you have that kind of set skills now, you will become very valuable to us in the near future. It can be like that. It can be, you can also find yourself where you just do, you guys have been doing what you have been doing, you build your CI tool, you push it to your Artifactory, you take Nessus, deploy it to SonarQube, and that is another aspect. Okay, so it all depends. The reason why we are giving you all this knowledge is like, at the end of this training, you are going to settle down to look at, because DevOps is very wide, no doubt about that. You are going to look at the tools that you are very, very comfortable with. The ones you are not comfortable with, please don't put it on your resume. They are going to screw you. But if the reason, I'll tell you my own experience. When I had my first training, the guy only just talked about the Docker. And We never did any lab, nothing. Just says, okay. We talked about Docker. That was it. But when I started picking up my interview, most of my interview was like trending. Do you know Docker? Do you know container? I was like, what is this Docker thing? That was when I took up the challenge. I said, let me go and get this knowledge. Okay. And guess what? Immediately I had the knowledge. I just did a couple of few interviews. That was how I got my first job. And got there. The first task that was given to me is just to pull a Docker image, or the tag and push them. Sometimes the job they will give me for 8 hours. I will do it within 45 minutes, and the next I will just be browsing my internet. So it's something that yeah, he laughing. I'm telling you, the boss will come back to you. Hey, Kelly, have you completed that? I say, yes, boss. Very good. Say, okay, awesome. Just give me a thumbs up on your Slack channel. But I've already completed that long time. I might even be watching soccer. Guess
So
what?
what do you do on your downtime in order to look like you're working in that time?
What do you mean that? You know, remote COVID, I don't know, directly or indirectly as me.
He just mentioned it. He just mentioned it that he's browsing or watching soccer.
I'm browsing, I'm watching soccer. I'm just
That's what he
browsing.
did.
What am I
Just
doing?
Let's
mention
come
it.
back to class, sorry.
Okay. So so for clarification, so we can say like Tomcat way is like the monolith, and this is microservice, the containerization.
See, don't forget, your Tomcat can also be on the container. Let me go to Docker Hub. Everything's here. Tomcat is also a container. It's here. See, Tomcat is here. See, it's here. You can put your application on the Tomcat. It can be on the container. You can put it on Apache. Apache is everything is already here. Apache, HTTP. See,
Yeah, let me add something.
What I'm trying to clarify is like, can we also say like Tomcat is like a microservice, or it belongs to
a Tomcat is a web server. Prince, can you clarify that?
Yeah. Let me see. Don't be confused with the terminology. Okay, the word container is also a generic term. Tomcats can also be described as a web container, but it is not a Docker container. When you say Docker container, we are talking about this.
Okay.
Containerization in the concept of Docker, okay, is a field on its own. Don't confuse it with, oh, okay, I'm using Tomcat, or I'm using this, and my application is this. Either my application is this, or is in a container. So, containerization is a field on its own.
Exactly. I said it's a
field on its own.
Yeah.
And it can interact with your current DevOps processes.
Right.
It's a field on its own. Okay. So your Tomcat, okay, you can have your CI/CD pipeline around your container.
Awesome. That's it. Yeah.
Process around your container.
Yeah.
You run your build, you check in your Docker file into your repository, okay, and you use your Jenkins to run this build.
Absolutely.
The image. Okay.
Push it to your repository.
Push it to your repo, and even run the container. Jenkins will do all those steps for you. You get.
That's it. Thank you so much. I think that just clarified the new stuff.
Yeah. So don't confuse it. Okay, this is monolith and this is no. Even your Tomcat can host microservices. You get. It can do so. Just see it as different, because when you now get to Kubernetes, what are you going to say? If you are comparing Docker container and Tomcat, when you get to Kubernetes, what will be the basis of comparison? You get. So just see it as a different field, an evolving field of DevOps. Okay.
Awesome.
We are talking about cloud native. This is the aspects of cloud native, Docker containerization and Kubernetes and all this. Did I answer your question? or give you further confusion.
That really gave me more clarification on it. Thank you so much.
Thank you so much, Prince.
And I remember Odinaka asked this question: what's the difference between web container and this your Tomcat deploy to container, okay, and this container we're talking about? That the deploy to container plugin, okay, in your Jenkins pipeline. That word deploy to container is a generic term. It does not mean Docker. Okay. Tomcats can also be described as a web container, but it is not a Docker container. So don't confuse the two terminologies.
Excuse me, sir.
Yes.
So so does it mean that Tomcat can only be installed in a VM?
No, Tomcat can be installed anyhow. See, every application, okay, right now they've developed an image from it. And if you have an image, you can have a container. Okay, you can run Docker on a container. You can run Jenkins on a container.
Yeah, Jenkins is on a container. You can have
You can run everything you can think of. Artifactory, you can run everything on a container.
Okay.
Yeah.
Yes.
See, it's right here. Jenkins here.
You don't have Jenkins. You just get the Jenkins Docker file, create the image. Once you create the image, you build it. Once you build it, map it to the port, put it on your browser. You don't need to install anything. You don't need to create a server and then start doing all those sudo apt-get, install Jenkins. You have everything already as an image. Okay, pull the image and run it. You see that it's gonna work.
Oh, okay. Thank you so much.
We can even try it now, but because of time, we are not gonna do that.
You can, from your command line, you can search. Just mention them. See what he does is goes into internet and pull all the images and that name. This is what we have here. You can also search by using search command. Okay, we have it here. If you see something, yeah, search image name. So as I said, the next stage of creating a container is from existing image. So in this demo, I'm going to use the CentOS image. CentOS.
Did we go through 23? This is 24.
Yeah, this is 23. As I said, 23 and 24 is almost the same thing. So
Got it.
but to get a better understanding, I'm using 24. Okay, it's the same thing. So let me explain to you right here. So I'm using the base image. Okay, let me clear my timing.
Yeah, sorry, I want to add something. Please, don't be confused. Okay. Remember, I told you this class was supposed to come in last week. Okay, so the numbering on your labs may be a little bit different. You guys are currently, from his documentation, is should be in 23, 24. But the labs you had from last week, you're already at 26. Okay, so just go with the title of your labs. I just changed the numbering so that you don't get confused. Okay. For those thinking 23, 24, but we just did 26. How does it relate? Okay.
So thank you, Prince. Now, if I do Docker images, you see the CentOS that have just been pulled. So this is the images I'm going to use. So right now I want to create my own image from this existing image. This is the purpose of this lab. So if you go to the lab, I said, put the image, I said, copy the image ID for a later use. What will I do? I will come in here, just copy this ID, okay, and put somewhere, okay. Say for instance, I put it on my, let's say I'm going to come back here and leave it there. So go back to the lab. He said, add the image ID to the command that has created the container base. So what I'm going to do, I'm going to do a Docker, okay, run iPhone IT. I'm going into the shell of the container. Where is my image ID? Image ID CentOS. Yeah, this is my image ID. Now look at it. I'll be using D. at the last, detach, come out of it. But in this command, I'm using IT, interactive. You can use IT, you can use exact. There's another command you can use to go into the share of a container, but there are some scenario you want to go inside the container, which we want to do. We want to install our application, then later commit the image. I say IT instruction the container to launch in interactive mode and enable terminal typing interface. Upon executing the command, a few command launches and moves you to a new share prompt. This is what we are going to do. If you enter this command, if you look at this command very well, now I am inside the root of this share, of this image. If you, this is root at IP 177. This is my host where my Docker daemon is sitting. But if you look at it, you say root as some kind of numbers here. Now I'm inside. Don't forget, my Docker daemon is sitting on Ubuntu. But right now, Linux is a different flavor of machine. If I do apt-get update here, I think F, it's not going to work. The reason, because this is, sorry, what is this? This is, I'm already inside a Linux CentOS image. So what I need to do is, if I do your, excuse me, your update, wow, see, it's going to work. So what you do is that after you go into the share, then you cannot install your application to it because you are already inside. I'm right here inside. So in this lab, we have, just to demonstrate it, we are installing this nmap just to demonstrate how we can install application. Press Y to continue. I think I also have another one here. Git, install Git. Okay. See, this is the version that's already installed. Wow. Now I already installed 2 applications inside what? My image. So if you go to this lab now, this is what we have here. Then we said, check the version to see, you see the version here, 7.1. If you do Git, for version, you also see it has already been installed. Git is the 2.27. So what will you do next? You will have to come out of it. So once you finish modifying, you have to exit. Just type exit command here to come out. You see, it came back. You are not outside again. So what do? The next thing you do run this command to list bootstrap and running command. You see that? So this is your container now. So what we have to do is I have to commit this container because I already installed my application nmap and Git into it. So you come down. I said commit the changes made to the image. This is how to do the command there. You just do docker commit, container ID, and your new image ID. This docker commit. Where is my container ID? This is my container ID. I put then what do I want to call this image that I just created? Okay, any name, Kelly app. We can say, we can take that. Just say application. So you can call it a new name now.
Must you put a hyphen on there?
It's that just kind of it's not a must. You can just put any name. I just decided to just differentiate it. If you now I already committed it now. If I do a Docker image, let's go to the lab. Here in this lab, we use the DevOps apps. It's not a must to put hyphen. You can put any name. As I said, in most cases, you don't determine the name. The developers will tell you, or your boss will tell you the name, the new name of the application. The reason is you use this name to differentiate because you have like hundreds of images in your repo. You use that name to be able to differentiate them. I think the next slide will be very interesting. We want to tag our image and push that into our repo. So now we already committed it this very one. So if you do sudo, okay. If you are root, sudo might not be too important. If you do just image, see, did you see that? This is what? Kelly application. This is what? Santos. If you look at Santos, Santos is 331 MB. If you see the new images which I just created out of Santos, is 462 MB. The reason is I installed 2 applications. It has its own kernel, binaries, packages, and everything. That is why the size keep increasing. So in real life scenario, you might see sometimes your application can be like in the range of gig, 1.2 gig. Maybe you have a lot of application running on your host. So this is how you create an image from existing image by committing it. If you, in case you are asking interview, but as I said, I haven't really seen that in real practical terms, but it's good for you to know it. Now, the next thing we need to do, we want to tag this image and push it to our repo. Please, guys, this is very important. Now, let me go to my repo. I think this, I'm going to go to my repo. How do you, in Docker Hub, see, you create a repository. If you put it on public and you take your image ID and give it to any person all over the world, they can be able to pull it without your credentials. But if I put it on private, for them to pull my image, they will need my user ID and my password. But for the purpose of this lab, I'm just going to put it on public. Then this is my user ID. I just said demo app. This is the name I'm calling this repo. So I click on create. You see that. Kelly demo app. This is the name of my create. So now I want to, this app which I already created, I want to push it to I'll do Docker tag. This is the application. I'm going to tag this image. Look at it. Sorry. Space. Then I'm going straight to come to my repo. I'm going to take this one. I'm going to take this one. Then tagging. This is the version. This is where I say developers plays around very well. They can have different versions. Say for instance, this is version 1.0.1. This is the first version that have just been developed. You press what? Enter. When you do Docker images again, did you see that? You see that my image, what? Has been tagged. Then I have to push. We do Docker push. I want to push. You come down, take that image that you cannot put this very one because you have not tagged it. You don't own ownership of this one. You have to push the one that you just be tagged. So I will come now. I will come and tag it here. Then the version is what? v1.0.1. Now, the first time you are going to do this is going to ask for permission, because right now I say push this image, which I've just tagged, which I have ownership, push it to my repo. Press enter. Did you see? You said request denied. So what do? You have to do a Docker login. Docker have to send a kind of API response to my repo to get a permission. We do a Docker login. It asks for my user's ID. My user is Kelly Amandi. Then it's going to ask for my password. Say, for instance, let me guess any password. It's going to tell me what error denied. Okay, let's try the original password and give us. Then let me try this original password. You say login successful. Now, if you try the original password and you are still having issue, ensure you are on root. If you are not on, if you are on Ubuntu, you will not be able to log in. Please ensure you are on root for you to do this aspect. This is where some of our people used to have some little challenge. If you're on root,
but you've been on route since.
I've been on route. That is what I said. I said originally I like to be on route just for permission issue.
I was about to ask that. Why are we on route?
Yeah, but it makes life easy for me instead of asking copy sudo. But sometimes some people will tell you it's not the best practice. But yeah, it all depends right now. So even currently right now, as I said, so I do sometimes forget to go on route. So I will start to run some command. It will give me an error, says permission. Then I say, I just look at my time. I will say I'm not on route, so I have to go on route. So to make this easy, always go on route to run your stuff. So immediately you pass in your original correct user ID and password, is going to say succeed. Now let me push it. I'm going to push. Did you see that? Docker daemon picks up this Docker image, immerse it up, and is pushing it directly into my repository. Let's see, it's pushing it now. This is, guys, please be very familiar with this. Now it already succeeded. How do I get my image? I will go to my repository, just refresh it. You will see my image here. Did you see that? This is my image. It was just pushed a few seconds ago. If you see, yeah, this is my image. Save. Okay. Save for whatever reason, the developers, they come back and say, hey, we have a new version of that application. They will call it version 2. Okay. Now they'll say, hey, we want you to push it to version 2. They come back again and say, hey, we are developing a new version, new feature, we want to add something to our code, version 5. They call you and say, hey, push version 5. Okay, let's push version 4. Let's see Docker daemon is smart 4. Did you see that? You say tag does not exist. Let's try version 10. It's not there. Now let's go to our repo to go and see if we have different versions there. Did you see all the versions? Now they can, your manager can tell you, hey, next week we are going to deploy version 1.0.5. So what you need to do is just to go there and take that word version and deploy directly into your environment. Any question before we go for the last lab for today? Which is, okay, I think this is installation of Docker Compose. What does Docker Compose is used for? It's for microservices. I explained earlier before that you have like EB, where you have these containers, they communicate among themselves. One of the ways to accomplish that is through a Docker Compose. So let me open that stuff so that we can get that one started right away. So that is the conclusion. This is the end of the lab. Guys, play around with it. It's very interesting. You see, it is all fun. Just
guys, I want to advise something. Okay, I know there's a lot of labs already. Okay, but my advice, based on experience from other classes, abandon every other lab and focus on Docker for just this week.
Yeah,
and complete it. If you can complete Docker, okay, you can always come back to the other ones without any issues.
Awesome.
But it is difficult to catch up Docker when you're trying to catch up and you're past the labs and you still have more things to come. Okay. Focus on once you get Docker and it sticks, it sticks.
Okay. Thank you so much, Prince. So this is a command to run a Docker Compose. Let me see if Docker Compose is not already there. If you see doing Docker, Compose, it's not there. So this command is going to create a Docker Compose. In our lab here, this is the command. You just copied. The next thing is we copy this command to create this Docker Compose. Then here we say, note, if your Docker Compose fail after the installation, check your path and use this command. But in this our case, it did not fail. So let's verify to see Docker Compose is there. Docker Compose. B. See, that's right here. It didn't fail, so we are good. The version is 1.27. So let me clear my terminal. That ends that lab. Now we want to create. This is the end. We want to go for the lab. How to create a microservices. This should go away. Using what? A Docker Compose. It's pretty good. Yeah. So we said you see containers 1, 2, 3, they are all there in a cluster. They communicate with the help of their virtual APIs. So this is what we have here. Take your time to go through them. These are stories. But in this our case, we want to make this directory to create a Docker Compose. WordPress. I'm going to WordPress. Then we use the YAML file to create a Docker Compose. Say VI Docker Compose. The YAML file. Press R, enter. Then this is a Docker file that has been written. That's written for this purpose of this. Let's see what we have here. See, we have WordPress here. We have a database as well. Here we have password, latest, WordPress that most of these bloggers use. So they will have two containers here. These containers will be, but after we create them, they will be able to communicate among themselves. So exit, save it. Then you use what? Look at the command that we use to run in Docker Compose. We use Docker Compose up. See, before we were using run. Excuse me, sorry guys, sorry. Yeah, Docker Compose up. But before we were creating from Docker, it was run. Then -D come out of it. Press enter. See, it's pulling the binaries, the kernel, the dependencies, it's building the images and everything to run them. Then it's going to create an image and going to put it into a running state, a container out of the image. So let's wait for it to continue. So WordPress is done. If I do Docker images here, we are going to see. You see that WordPress is here. It's using my SQL as the backend server. So we have the, if I do Docker ps-a, did you see that? My SQL is up 24 seconds ago up. The exited, as I said earlier, is in a stop state, up is in a running state. So what do? We need to access this our WordPress. What we do, we copy the IP address of my host. See, copy it, yeah. For me, is it A0? Yeah. Container is still coming up. Let's see. Let's give it some.
You have to open
That
that.
IP is not right.
Oh, okay.
That IP is not right.
Oh, it's not right, right?
Yeah, you didn't type it very well. You can check.
Oh, sorry. Okay. Normally, okay. Let's see.
Check the port if the port is open. Too.
Open, right. Let me see. I think the port is in 10. Yeah, port, that port is 0. It's not there. Right, sorry. Port is not there. So what we do, we just open that port. It's 0. Anywhere and save it. This thing, there's no way you can do a shortcut to it. You have to follow it. You see. Let's see. Did you see that? Now this is your engine WordPress analysis. Let's install it. Those you guys that have skills for web development, I think you guys can do more about this stuff. Put the password behind here, validate the data. Then put your information here, then you install it, log into it, put your password. This is your WordPress. Now, this WordPress has a back end, which is my SQL. If you know MySpace, a database server where you put your information, like the user's ID. I think you guys did the, what is the name of that database again, Prince? I forgot.
Yeah, they did Postgres.
Postgres, okay, yeah. There was this other one we have a class of. Did you guys did that? Though it's a separate class. The one that has that certificate. Liquid base. Yeah.
They did not
show interest in that. Okay,
that's they didn't show interest in that. Well, I think I didn't really announce it that much. But we do liquid base database migration if you're interested.
Yeah, database.
You write exam after 1 week, 50 questions, and you get the certification.
This is your WordPress. You can customize it. You can even do this as a demo and create your own website of a state. I think we are 8 minutes past already, but I can stay on to take your questions. I think that concludes our lab for today. Tomorrow, we are going to look into orchestration tools. Now, we created container. How do you manage this container? If for whatever reason this container is dead, it can happen. It's not responsive. What will happen? We have a tool that is responsible for managing this container. You will be hearing a lot like orchestration tool. We'll be looking at Kubernetes. We have about 3. We have Docker Swarm, we have Mesos, and the Kubernetes is the one that is most popular, which is really trending. There are still some few companies, like 20% that might still be using Docker Swarm, which is good, but a lot of companies, they are moving into Kubernetes. Kubernetes was developed by Google, I was told, but right now it's maintained by Open Native forum, like you have a lot of developers all over the world that is contributing. Then each cloud providers, they have their own. AWS has their own, which is called Elastic Kubernetes Service, which we'll be making use in this lab. Azure has its own, I think Google Cloud also has the GKE. So it's very, very interesting. In fact, they go together. Whenever you see Docker, you see Kubernetes. You see Docker, you see Kubernetes. Or you see Docker, you see Docker Swarm. You see Docker, you see Mesos. Because that is what will help us to manage it. How do you scale it? How do you get a replica set? How you deploy them? How do you expose your service? All those kind of things. That is what we'll be looking into. We have said a lot for today. As Prince said, I expect you guys to keep your hand dirty. Please make sure you go through this video again and watch it. And after that, watching it, try to practicalize everything that we have done. It's pretty straightforward stuff here. And if you have anything, you can put your question on our general forum. I may not respond to one-on-one chats with you, okay? And sometimes you are asking something that is related to something we already taught in the class and we have it in the video. I'm very busy right now, but I might be able to come back to you maybe after my I close for the day. I can have a one-on-one with you, but I will not just come to you and say, hey, maybe you are just trying to tag an image you're asking me. I didn't want to tag that. We've done that here. We have the video for that. So that being said, ensure you play around with minimum 10 to 15 Docker commands. If you are very good at that, I think you are good to go. Let me take questions before we wrap up today.
One last comment. I will tell you my own experience, okay, on with Docker. I had one face-to-face interview when I started some years back, and I had done everything, phone call, is face-to-face, the final stage, and I had mesmerized them with so many stories that they are wild, okay? So there were three, the manager, the two teammates, DevOps guys, and they now brought a laptop in front of me and they gave me a Docker file and they say create an image. I had no clue. Something as simple as that, I did not know how to do it. That was how I lost the $75 an hour job. On my very first, when I was just done with DevOps training, and just that simple line, run a container from this Docker file. They gave me the Docker file, okay? And the basic things inside, I remember, from copy and the port expose. And they say, just run, can you run this? And I did not have any clue, okay? So this is very important, all right? You have 1 week to complete all this. You can complete all these labs in a day.
Yeah.
Then you can now go back to your other labs. Don't let this one, oh, I have pending labs. Finish this one first, because this one is not dependent on Jenkins. It has nothing to do with Jenkins, Artifactory. It's a whole field on its own. Okay? I just wanted to throw that in. So if you have your questions, please ask, and let's call this a wrap.
Hello, Prince. This is Solution. Hello?
Yep.
Mr. Kelly, please, I just have a general question. Like, for the first time, I think I'm trying to, because I see DevOps as something that's a little bit wide.
You're right.
And I'm trying to see where my strengths supposed to be.
Yeah.
So I think I'm having a little bit interest in this. So what did you think I must have as a basis and to be expecting in the field, what I should have as a basis, and how do I go about developing more on it if I really want to go to through this route?
See, that is a very good question. I really appreciate your lesson. As you said, it's very wide. Like, if you are very comfortable with all the labs that we taught today, I guarantee you are already like 90% or 95% ready to work as a DevOps engineer, especially on the area of containerization.
Okay.
I can share you some more that if you want to really go more deep, because it's pretty very wide. Like tomorrow, we are doing orchestration. Orchestration is wide. I kind of want to take it further. I want to take it beyond your scope. So if you are in that kind of situation, you can come to me one-on-one. I can give you details. Even our guys that are still working now, of course, we'll be training people and they'll be getting jobs. Some of them still consult me. They are having issues. They still come to me. We still look at it together. But as I said, it's very interesting. I will encourage all of you, please, take this stuff seriously. It's very easy. It's interesting. if you are good at it, it's fun. Imagine you just put, like what Prince said, just build that image. I lost $75 an hour. That was before COVID, but thank God COVID is, no, I would say thank God, sorry, let me take that word back. Because well, with COVID now, a lot of things is like remote now, because I'm working directly from my bedroom. So, but before COVID, they will ask you to come into office, bring your laptop, you have to build it on in their presence. So, please take, if you take this lab, if you can conveniently do this lab without my input, say, hey Kelly, I'm stuck, I give you a thumbs up. My friend, you are good. Because everything you should be working about, as I said, put your image, deploy your image, tag your image to your, that is what you'll be doing. Don't look at the Docker file. As I said, developer will take care of that. So I don't know if that answers your question.
Perfect.
So at the end of this training, this is what we are going to tell you. We are going to have another session for that. You are going to look at the tools that you are comfortable with. I used to tell people, if you know you are not comfortable, after this training, I think one of my colleagues will be coming in for Terraform, okay? Then you settle down. We'll give you a kind of template. All the tools will be there. But if you know you are not comfortable with that too, please don't put it there, because your potential interviewer may screw you around that area. So like I'm taking interview and I do ask people, do you have knowledge about Ansible? I learned that you guys did Ansible already. You did the Tower, which is, I don't even know Tower. I'm still learning it from Pristy now. I only know more about the open source, which is the open source one. Even was it like about last week I see consultant Prince. I say, hey, Prince, he say, you just look at my project. I say, why don't you go with Tower? I say, these people don't want to pay. And this is the truth. Tower, you have to pay. I think it's something that has to do with subscription, but he was saying give them the open version. I said no, I know those because these are multi-million-dollar companies and they don't want to pay something about 100,000 in a year. So it's very good. And sometimes you are taking interview for Ansible, they will ask, do you know Tower? If you say Tower, oh, thumbs up. You're already having an advantage over your competitors. So at the end of this training, look at the tools that you are very, very strong with. They put that one in your resume actually. Believe me, the market is there. It's an hot cake. Trust me. You have your role to play. You will have to do a lot of sacrifice. I used to tell people, if you're a Christian, after you do your morning devotion, pick up your computer and keep your hands there at least 1 or 2 hours every day. Every day. When I started, okay, I don't want to. I met Prince P introduced me to DevOps. Now he's my boss. Okay, I was riding Uber. But every day I used to ride Uber. Every day I spend minimum 1 or 2 hours on my computer. But the rest is history now. So you have to pay some little sacrifice that time. I know a lot of us are busy. We have our family issue. We have our job. But even at that, fear it, keep your hands dirty. If I say keep your hands dirty, I mean practicalize. Go computer, create VMs. I think, Prince, we have one website that says they can always spin up VM without going to AWS. Let me remember. Katacoda. Yeah. Katacoda. Yeah, correct. Yeah. Okay.
Like what he's talking about right now.
Yeah.
For example.
Correct.
You can play around if you don't want to just go into your AWS. If you are finding it a little bit, just come to katacoda.com.
Yeah.
You can learn so many stuff here.
A lot. I learned.
Like container. It will just give you a container environment already.
Yeah.
You just run your commands.
Everything.
What is a container? How does it work? Foundations and everything.
Right.
For example, what's a container?
Yeah.
10 minutes to learn. You start the scenario.
See,
the environment for you.
Straight
I tell you what to do. Okay. For example, see this process: Docker run, and DB and that. Okay. Say containers are just so it will help you practice
everything.
Some commands, some things.
Please go up and click on that. You see, click on that arrow, the last part.
This one.
Click there. Did you see that? It's demonstrating. You can't find it. It just provisioned it for you. You see that? You can go through that everything, just like what I did going to my AWS. It's free. I think these guys are based out of Singapore. You do Docker, PS, all those 10, 50 command, come and practicalize them here. Just go after the other. You'll see everything here.
Okay. So it's like you're entering the command, it's explaining
exactly. Yeah.
Everything to you. You are seeing the process as it's running.
Correct.
Yeah. And you could also, Katakoda is really, really rich. You can also learn whatever technologies you want to also learn too. Like if you want to do Kubernetes, you can do it here.
Yeah.
Yeah, you can do it too. If you just want to practice Linux, okay, whichever machine, CentOS, Ubuntu, you can start. Let's say Ubuntu 16.04. It will just give you the environment there, and you can do anything you want to do. You can do your sudo apt updates, and it will update it. This is a virtual machine,
right?
Okay, it's as if it's a real Ubuntu server. Everything you see, it will work. You do your ls, mkdir, whatever command you want to do, you do it here. Okay, take advantage of this. Okay. I think we'll call this a wrap. We'll run over.
Any question before we call it a wrap? Maybe.
Hello, Kelly.
Yes, sir.
The introduction to Ediruka, you said you're going to download this.
Okay, I will try to get there. I will try to download that. I'm still trying to figure out how to get. I will share with you if it is possible. As I said, I will share.
All right, no problem. Thank you.
I appreciate it.
Yeah.
Sorry.
I have a question. This is Serge. Is this a free? Katakoda is a free.
It's free. It's free. Just create an account. You are good. It's free.
Okay.
Share the link with them. Please put it on the Zoom chat. It's free.
Okay, it's there already.
Okay. Awesome. Any other question, guys? Liverpool, you guys should win this game.
Hello.
But stop recording. Make it not enter that one.
Okay.
Hello.
Yeah.
Hello.
Go ahead. Yeah, go ahead.
I have a question for Prince, right? I know we've gone overboard, but for
let's say if you guys can say I'm here, I'm doing nothing.
Prince, for the labs that we're doing, is there any way like tomorrow we could just you could help us out where we stock and all that?
Then maybe you already said that it should put.
Where? I don't understand.
I'm stuck on lab 22. Yeah, where did you
see the point? Yeah, see the point. I know I've repeated this lab. I've been hammering, try and get your labs up to date, get up to date, you know. I've been hammering that all week. Because I don't want situation like this to come up. Okay. So for this scenario, you're gonna stop every other lab and focus on this. When you're complete with this, okay, then we can